All right, guys, eyes up. Guys, just real quick announcement. I have not graded yet, so I still haven't looked at Edpuzzle yet. Okay. I know I've been telling you over and over again that I'm going to, but I haven't yet. So do me a favor. Everybody eyes up here. Right? I want to see everybody's eyes. If you're not looking at me, I know you're not listening to me. So, eyes up front. So yesterday we talked about the heating curves of, what was that? Boiling point and melting point are on them, but what was that? A graph of? No, that's what it was measuring. But what was it about? What was the graphing about? What are we talking about? So if you just say boiling points and melting points, what are we talking about though? It's in Celsius. It's in time. What kind of matter? Water. There we go. You guys made that way harder than it should have been. Water. We were walking. We looked at water, right? Remember, this was the heating curve for water. This was the heating curve for ice, yeah, ice and water. Those were the two different ones, right? So remember, when we go sub-zero, right? When it's 0 degrees or lower, water is in what phase?
Liquid.
No. 0 degrees or lower.
Oh, solid.
Solid. Yeah, it's frozen, right? Ice. Okay. Remember what that line was about? Why was there a line right here? Because it takes a long time for stuff to change temperature, right? It takes a long time because all of the particles have to change, right? So we called that a plateau, just like in social studies. Well, all right, then we go liquid, right? Liquid from 0 to 100, and then over 100 is boiling. So we have increased kinetic energy. Remember that part? Energia kinetica or cinetica? I cannot remember how to say it. So today, we're going to continue talking about the kinetic energy of molecules. Okay, kinetic energy of particles. Let me turn the music on. Just 8 papers. All right, guys, so today we're going to talk about the dry ice bombs to start out with. Who remembers with the dry ice bomb video? So, tell me, what happened with the dry ice bomb? Bomba de, what is it, bomba de yellow? Yellow? Bomba de yellow? Yellow? It's the same, look, it's yellow. Sounds like yellow. Yellow. So, bomba de yellow, what happened? Okay, happened. What happened? Why did they explode?
Pressure.
Because of what? Pressure. So remember, we talked about number 2. We just talked about pressure. What kind of pressure was that?
Gas pressure.
Good, gas pressure. So number 3, we talked about what type of pressure was that. So number 1 though, what was the most important thing in those videos? So somebody explain that. Why was it the cap? Go ahead. Listen up, we shouldn't be talking while she's talking. Make sure you project your voice, sound confident.
Because the cap,
Go ahead.
because the cap closed the container and we need the container to be closed for the pressure to build up.
The cap closed the container, which made pressure increase or decrease?
Increase.
Increase inside the bottle. The bottle eventually exploded because of all of the pressure inside of it, right? What causes that pressure? Gas. Good. So when they're heating, or when those, so think about it. This is an example of, it's in the new agenda. What is it? This is a? It is a water bottle. That's a great job. No, it's a?
Liquid. Solid. Container.
Closed. What are we answering?
Closed
System. Thank you. Closed. Sistema. That's what I said. Yeah. Of course. All right. So, what would make it an open system? If we left the cap off, that would be an open system. Can an open system build up pressure? Negativo, right? It can, but it's not going to. As not at the point that it's going to explode. Yeah. Right now, we're going to be answering the question on the paper.
We're answering the question.
Yeah. Number 1, 2, 3, 4. So, write those questions down. And then number 4, I want you guys to talk to your table. Okay, this is your table. That's your table. That's your table. Talk to your guys. After you guys write down 1, 2, 3, you just talk about it. So, on this way, right? This way. We're going to hablan. And then we're going to describe the enargio canal. So this is going to be adding pressure to a closed system. Okay, adding pressure to a closed system. Number 1, what is the most important thing? So we should be writing it down, right? Escriben. Velvet.
What's the title? Adding
Add pressure to a closed system. It's right there in the agenda. Okay. So I'm going to give you about 1 minute to talk to your table and try to summarize that kinetic energy of the gas inside of that bottle. as it's exploding. Okay? As it's exploding. Remember the play-by-play thing we did yesterday, right? He's at the 10. He's at the 5. No? Remember? No, you don't. You listen to the video. Yeah, don't do it yet. Not today. Not today. Maybe outside, I don't know. Unless that's against the rules. I don't know what the rules are.
Science.
Mr. Rice, can we answer the questions right now?
Huh?
Can we answer the questions right now?
Yeah, answer. So we should be writing these down on that paper, right? So 1, 2, and 3. And then just even, right? Explain. Talk to each other. So I should hear talking to each other. Yeah, you can just write number 4 and then write the, you don't have to write the number. Well, yeah, write the question.
Mr. Rice, you know your last grade? Last grade. Isabella? Isabella's friend? She said that you like them listen to music. Why can't we?
Listen to what?
Music.
There's
We like our own music. She said our own music.
yeah, I bet we do. Everybody's always got suggestions for music.
Why did you let go?
Can't party that hard. It's still good to do the class. Alright, so we're talking, let's talk. Gentlemen, we're talking about the kinetic energy, right? Kinetic energy of those molecules, number 4. You should be talking. We're working together right now. So we should be talking, talk. I don't hear any voices. There we go. Makes us feel like we're a teacher, guys. Oh my gosh. No, not right now. See? Everybody wants to leave. We should be talking, right? So everybody knows. Balance ideas. Blah. So pressure is increasing or decreasing? So how does the particle look like when you're increasing pressure? Expanding? How do they expand? Do they contain or do they expand? What about moving? Moving faster or slower? Faster. Good. That's what you should be writing for number 4. See, you're such a nice character. So pressure's adding. No. Okay, who's strong? Okay, that's worth the answers. Okay, we got a couple examples to do today. Who's strong? Okay, everybody's almost up here, right here. Okay, squeeze this thing. Ready? Stand up. Stand, everybody has to see. Wait, no, look, everybody has to see. You're getting like the whole. Over here. Get on back. Get on back. In front of the class. So everyone can see. Alright, here we go. Don't point at anybody. Ready, set, go.
Excuse me,
Hold on.
No,
Ready, set, go.
Where's the bottle?
Alright, what happened? Exploded. Why did it explode? There was pressure. That was good. Hey, I did it the first period, and it was like, oh, that was easy. And then I went to do it before this period. I was like, I better get somebody to do it because I haven't worked out like 100 periods. So check it out. What happened in? What was on it that made it build up
The cap.
pressure? So it's got a cap. So is this an open system or a closed system? Closed. Closed. When it popped. Now what is it? Now it's an open system, right? Abierto, or what is it? Cierto. Yeah, see? All right. So we're gonna do something really quick. So everybody up. Levántense, por favor. Okay, push your chairs in. Push your chairs in. Make sure nobody trips on anything. Okay. We're gonna simulate gas particles. Eyes up. We are all individual gas particles. Mr. Maynard, what are we?
Gas particles.
You're what? One or two of them? I'm only one of them. You're only? One. We're all? One gas particle. We're all in a? Container. What's another way of saying that? Closed system. If I open the door, I know half of you guys have run away, so that would be called a open system. All right, so here's what we're gonna do, guys, and I really do want you to be careful, okay? Usually I do half the class. You guys are mini numbers, all right? There's a lot of people in here, so I'm gonna clap. When I clap, I want you guys to step. So if you're in band, you'll know what I'm doing, right? But we're walking around the room. This room is a closed system. How do gas particles act in a closed system?
They move faster.
They move, right? They move in straight lines until what? I hit something. Oh, bounce off. Oh, bounce off. Oh, bounce off. Oh, bounce off, right? So, ¿entienden? We understand? ¿Comprende? Okay. So, very important. Muy importante. Don't hurt each other. Okay? It's not a mosh pit. Make sense? Circle 2000. All right, here we go. Everybody push your chairs in so nobody trips. You can move around. On my clap. Set. Step. Okay, stop. All right. What were we doing?
We were moving.
Moving. What were we?
Moving.
Particles, right? We're all particles. All right, so now we're going to do this. Everybody's got to be on that side of the room. You can't be behind my desk. Ready, set, go. Okay, here we go. Same thing. There's an invisible wall right here. Same thing. Ready? Set. Step, 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 step. You can't go that way. Step, step. You can't go that way. Step, 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 step. Welcome back. All right. Nice. So, what happened? Are there more of us in this part? Are there more of you guys in this part? No. We started with the same amount of students in the first part, right? What is there more of? In the first part there was more? Room. In this part there's less? Room. What's another way of saying that? Container. What's a container? Like the open or closed container, right? What's another scientific-y way of saying that? Starts with a V. Sometimes when I'm mad, I turn it up.
Volume.
There you go. Volume, right? Volume. The space that the gas containers have is called the volume. All right, go ahead and sit down, guys. Good job. So, when we reduce the volume of the container, go ahead, guys, take a seat. Please take a seat.
The camera.
Okay, check it out, guys. So, we just did an experiment, right? There were 2 experiments. So my super strong guy over there squished the bottle and it popped the cap off. We also did a particles experiment where everybody was a particle in one big container, right? That makes sense? Did everybody understand why we were moving around?
Yeah.
Who can explain to everybody why we were moving around? Go ahead, tell me.
Because we are the particles.
We're the gas particles inside the room. Okay, we're simulating being the gas particles. So we're bouncing off the containers. Does that make sense? Okay? Give me like a thumbs up or like a, yeah, I understand. Hey, that makes sense, Mr. Rice. Right? Okay, so bouncing off the container. Did you guys bounce off of each other a lot more the first time or the second time? The second time. So, what was the difference in the second one? Less space or less volume. So when you take something and take the volume and reduce it, we did it by about half. What happens to the pressure? Why? There's less space for what? There's less space for movement. There's less space for particles. So what happens to the particles? They move faster. Más rápido, right? Más rápido. They move faster. They collide faster. And that starts pressure, right? Pressure adds up. So volume, or changing the volume of a container, is one of the ways that we can add pressure to a closed system. Right? Changing the volume is one of the ways we can add pressure. All right, so right now we're going to watch a video, and then we're going to talk about some stuff and draw some stuff, and we're going to be done.
Yay!
All right, hold on. I'm going to make sure all the subtitles are on. As we do that. All right. So everybody's eyes up on the board, please. All right, here we go.
Let's imagine a room filled with these balls constantly moving around in different directions. This is how molecules get against them. In this video, we're going to discover more about amazing gases and the effect temperature and pressure have on them. Have you ever wondered why the cork explodes out of a champagne bottle? Or the fizz when you open up a shaken bottle of Coca-Cola? This is all to do with gas and pressure building up inside the bottles. So let's have a look at pressure and gases in a little more detail.
You started off because I could.
Who didn't like playing in ball pit when
Alright,
they
so
were a
everybody
child?
eyes up,
Now
yeah?
let's imagine a room filled with these balls constantly moving
You
around.
guys ever played one of those?
No.
They had those at McDonald's when you were little?
Yeah.
The little ball pits that you jump in?
Yeah.
They had, well, they used to have them in rocket jump,
They
right?
got to their
Yeah.
They have them back in
In different directions. This is how molecules in a gas move. In this video, we're going to discover more about amazing gases and the effect temperature and pressure have on them. Have you ever wondered why the cork explodes out of a champagne bottle? Or the fizz when you open up a shaken bottle of Coca-Cola? This is all to do with gas and pressure building up inside the bottles. So let's have a look at pressure and gases in a little more detail. Gases exert a pressure on any surface which they are in contact with. The more particles that hit the walls of the container, the higher the pressure. Like when you shake a Coke bottle, and as it fizzes, the bottle feels harder than before. This is the gas particle pushing against the plastic bottle. So we have the equation. Pressure is force per unit area. We also see the effect of pressure in gases when we blow a balloon up too much, and it pops. This is because we've increased the pressure of the air molecules pushing against the rubber balloon too much. Heating also increases pressure. Why is that? As a gas is heated up, the particles gain more energy and move around more quickly. They then hit into the walls of the container harder and more often. This understandably increases the pressure, and if the pressure is too great, the container can burst. Again, think of popping balloons and bursting tires. Ever read on your deodorant can a warning that says not to leave it in the sun? This is because inside the can is a
Okay.
gas, and as we just discovered, heating up a gas
Anybody have a deodorant can like that? Anybody ever seen a deodorant can like that?
I have one, but it's at home.
So it's like the Axe cans or even like hairspray. Sometimes they used to have all hairspray and that stuff, right?
I have extra.
But it's a can that's pressurized, right? And when you press the button, whatever's in there comes out, right? So if you leave it in the sun, right, there's warnings on it that say don't leave it in the sun.
causes the pressure to increase and can result in that can exploding. Not a good idea. So what happens if we then cool down the gas? This time, the particles have less energy, and so less pressure is being exerted on the container, which is why balloons shrink and become sad and saggy. Now, it's time for something none of us like. Needles and syringes. Thankfully, there are no injections for us today. We're just learning that needles and syringes work due to pressure in gases. When the plunger of a syringe is pulled out, it causes the volume in the chamber to increase. This increased volume causes the pressure inside to decrease. Now we have created a vacuum that wants to repressurize to normal atmospheric levels. Since it's a sealed system, except for the needle into your arm, the only fluid available is your blood, which gets sucked into the chamber. Your blood then reduces the volume, and so the pressure increases back to normal. Pause the video and fill in the missing words.
Pause it.
Did you get them right?
No! Ah! Stand by. Don't look, close your eyes.
I already looked.
No! Okay, okay, number one, check it out. Increase or decrease the volume decreases the pressure of gas.
Increases.
Good. What about number two? Increasing the temperature in a set volume. So that would be like this thing right here, right? This is a set volume, closed system. If I increase the temperature inside of it, would that increase or decrease the pressure inside of it? Okay. And then last but not least, if I increase or decrease the amount of volume, amount of molecules in there, would it increase or decrease the pressure? Increase, right? It's like a bike tire.
Mental soda. Why does it like explode or fizz itself around?
Did you get them right? So there we have the effects of volume, temperature, and molecules on the pressure of a gas. I hope you enjoyed today's lesson, and I'll see you next time.
Please like and share our videos with your friends. If you have any questions that you want help with, just comment below.
Okay, check it out, guys. For the rest of the time, I want you guys to draw and explain. At your tables, you can talk to each other at your tables. Draw and explain the 3 different ways that we can add pressure to a closed system. And I want you to try and use, not the video, sorry, I had it on the wrong side. There we go. So I want you guys to draw and explain both things in there. So all the 3 different ways that we can increase pressure in a closed system. Okay? Use the terms kinetic energy, thermal energy, pressure, volume, and increasing and decreasing. Yes. Hint, you have all your notes, and I left most of my notes up. Okay? All right. We have about 10 minutes to get this done, guys. And then we'll talk about it right before we leave, okay? Yeah, hurry up. No, don't worry about it. Ask your friend. On the paper. Yeah, anywhere on the paper. How do you spell what?
Are we redrawing that? What do you want us to draw?
The 3 different ways. Not today. This should be in our science textbook, right? Or not textbook, but the 3 different ways that we can add pressure to a closed system. That's what you're drawing. So, So this is your closed system, guys. If you need an example, right, this is your closed system. There's 3 ways we can add pressure to it. I'm not going to do the rest. The rest you have to draw. If you just want to draw this one canister, remember it's a closed system, so it has a lid. So there's the important part is knowing the 3 different ways that you can put more pressure in. The first 2 are obvious. The 3rd one's not so obvious because we haven't talked about it. It's not hard. What are we adding to? Adding more of that. Yeah, go ahead. I decided to draw right here.
Like I mean,
What are we supposed to
Just be specific.
Oh, somebody's screaming it.
That's adding more gas. So that's not. So once you put one more increase the rate, it's not going to be taking these.
Okay, guys, we have one thing to talk about before you guys go, okay? Remember, the first question was, how can we add pressure to a closed system? So, if we take the tennis ball sleeve, that's what these are called. These are called tennis ball sleeves. So, how can I add pressure to this? Give me one way we can add pressure. Okay, so she said squeezing it. How do I add pressure to it when it squeezes? What's that actually doing? I thought I heard it. Go ahead. I keep hearing increasing / decreasing, decreasing, increasing.
Increasing the volume.
It's decreasing the volume of the canister. How? I'm forcing, right? Look, by doing the way you did that, I'm forcing the air to go to one side of the canister. Just like when we stood up and everybody went to one side of the room. Right? And we kept moving around. There was more kinetic energy over there, right? We bounced off of each other a lot more, so that was supposed to be more pressure. So, decreasing the volume, right? Volumen? Volumen? Yeah. Decrease. So menos. Okay. Menos volumen. Más pressure. Sí. Also, más caliente.
Yeah.
Right? Más caliente. What's caliente mean, guys? Hot. If I add heat to this, that's the second one, right? So somebody tell me, how does adding heat to this add kinetic energy or add pressure? Help me out. Explain it. It moves the particles faster, right? And it increases the particle motion. Increases the particle motion. So when the particles bounce off each other faster, it is más presión, right? Faster particles, más pressure, okay? And then what's the last one? What's the last one? It's hard with this example. What if I put one of those pumps in here and I pumped in more air? Right? If I pumped in more air, it would be more volume, right? It wouldn't be able to hold it, and then boom. So you can add more particles, right? You can heat the system, or you can decrease the volume. So those are all three ways. So now you know, it's always half the battle. All right, guys, you got 2 minutes to go. Oh yeah, that's right. I know. I always think it's 19. Adios, guys. Have a great day. Back it up. Any questions for me? Yeah, absolutely. Yeah, we do it twice. Yeah, do it twice. Adios, guys. Have a great day. Have a good one, guys.